I'm not 100% sure what's going on here. Like, I can't. You guys are finding the stream, which is great, but I can't get the image to come up on my YouTube channel, my temporary YouTube channel. Anyways, I'm Skip Alzheimer. I want to show you 16 millimeter films, and I don't want to have to spend time figuring out what YouTube is doing to me now. So, I love you guys, but here are some films with some puppets. Enjoy.
Guess the correct number of jelly beans in the jar and win the full jar of candy.
Winner to be announced Saturday afternoon. How many you guess, Kaz?
590. How about you, Oni?
752.
Oh, that's way too many.
Well, we'll find out tomorrow afternoon.
Want to come play over at my house?
Well, Monday's the finals of the spelling contest, and there's some hard words I better study up on.
You're the best speller in the school, Oni. You're sure to win. Hey, look what I found.
Oh, lucky you. You know when you throw a horseshoe over your shoulder, that your wish will come true?
I wish I win the jar full of jelly beans. Hey, watch what you're doing. It's my good luck that I have a hard shell, or else that would have hurt. Tennyson, I was just looking for good luck. Well, watch where you're walking if you're looking for good luck.
Look what you did.
Oh, I didn't see it. I'll walk back.
That doesn't count. Walking under a ladder brings bad luck.
But what about my good luck in finding the horseshoe?
Well, this cancels it out. Now you can't possibly win the jar of candy. I gotta go home and study my spelling, cuz I'll see you later.
Are you all set for the spell, Taffy?
I have a little more studying to do, Daddy.
The only one who spells as good as Taffy in school is Oni.
He's very good, but, well, if I study real hard, I can win.
How do you spell vanilla, Taffy?
Vanilla. V-A-N-I-L-L-A.
Right. Dessert time.
Ooh, I love vanilla ice cream, but I love chocolate, too. Chocolate. C-H-O-C-O-L-A-T-E.
Spell believe.
Believe. B-E-L-I-E-V-E.
Right. How about wizard?
Wizard. W-I-S. No. W-I-Z-A-R-D.
Right again. Wow. You really are a super speller, Oni. You don't have to practice anymore. Let's go to Strudel's. Today is the day they announced the jelly bean contest winner.
Well, I can't go yet. My mom wants me to wait for the delivery man from the supermarket.
When's he coming?
Sometime this afternoon.
Ooh, there he is.
Hee-haw, mail for the Onis.
Oh, hello, Mr. Flippo.
What's wrong, Oni? You're usually glad to see me.
I thought it was the delivery man.
Well, I'm delivering a special package to you.
Me?
All the way from Egypt.
Oh, wow. Thanks, Mr. Flippo.
You're welcome.
I got a package from Egypt, Butch. It must be from my Uncle Oscar.
Egypt. Ooh, it sure looks mysterious. Let's see it. Let's see it, Oni.
It's just a little stone.
Gee, that's not very much at all.
Let's see what the note says. Dear Oni, I'm now traveling in Egypt. This is a scarab.
Scarab?
S-C-A-R-A-B. It's a beetle, Butch.
What good is a stone beetle?
Well, it says here, in ancient times, the Egyptians carried these stones as good luck charms. The usual color was blue of the sky or the green of leaves and grass, the colors of nature. I hope it brings you good luck. Love, Uncle Oscar.
Ooh, wow.
A real good luck charm of my very own. Look at it.
Oh, now you're sure to win the spelling contest.
Yeah, And I sure wish the delivery man would get here so we could find out about Strudel's jelly bean contest.
Supermarket delivery.
Thank you.
Careful, it's heavy.
I got it.
How about that?
I wished he'd get here, and the doorbell rang right away.
Ooh, your good luck charm did it.
Oh, boy. You know, I'm going to keep this in my front pocket so it'll be with me all the time. My lucky Scarab. Oni! Oni! Hey, Oni! Hi,
Hey, we're going over to
Scarecrow.
Strudel's.
Come on, hurry. You won, Oni. I did? There were exactly 752 beans in the jar. Let's race there. Okay, but you know I run faster than you. But today is different.
On your mark, get set, go.
I win. I win.
Wow, you sure did, Oni.
It's my lucky Scarab. See? Come on, let's get my jar of candy. There's enough for all of us to share.
Wait till you hear, Taffy. Oni has this blue stone beetle. It's an Egyptian scarab. A good luck charm his uncle sent him. It makes him win everything. Now, you don't stand a chance to win the spelling contest.
Well, I don't believe in magic. You're just saying that to upset me. That was a good basketball game, Butch. You didn't win this time.
Yeah, your scarab sure has brought you lots of luck already.
Gee, maybe it'll always bring me good luck. Maybe I could become mayor of Forest Town.
Or even president. Ooh, let's see it again.
Sure, it's not here. It's not in the pocket where I put it. It's gone.
Oh, no.
Help me look for it, Butch. Oh, no.
We've looked everywhere, Oni, and can't find it.
What am I going to do without it? I broke a mirror, and that means 7 years bad luck. And my bad luck has already started. I tripped on a rock coming over here and hurt my knee. Maybe your uncle can send you another scarab. I need it tomorrow for the spelling contest.
But you're a great speller, Oni. You got into the finals.
But the finals is when I really'll need my good luck. 'Cause now Taffy's sure to win. But you were a super speller before you had the scarab, Oni. No. Nope. I'm just not going to be in the contest tomorrow, that's all.
Oh, come on, Oni. You gotta do it for us.
For the Yakimo Club.
Yeah, for the Yakimo Club.
Without my lucky scarab? Oh, I don't know. I just don't know. Oh, there's a blue bug. A beetle. A blue stone beetle. It's Oni's good luck charm. I wonder if it works. I'd better give it back. I will, after the contest. Mysterious. M-Y-S-T-E-R-I-U-S.
Oh, I'm sorry, Oni, that's wrong. Now, Taffy, you try mysterious.
Mysterious. M-Y-S-T-E-R-I-O-U-S.
Right, Taffy.
Oh, I knew it. She's doing better than me. I could have spelled that one right if I'd had my scarab.
Oni, spell possession.
Possession. P-O-S-S-E-S-S-I-O-N.
Correct. Now, Taffy, spell superstition.
Superstition. S-U-P-E-R-T-I-T-I-O-N.
Oh, I'm afraid that's wrong.
Now, Oni, if you spell superstition correctly, you will be the winner.
Oh, I didn't study that word. Superstition. S-U-P-E-R. S-T-I-T-I-O-N?
Correct. Oni is this year's spelling champion.
Isn't it a beauty, Cuz? Congratulations, Oni. You did real good. Thank you, Daffy. You did real good, too. I guess this is yours. It doesn't work. You stole it. No, I found it yesterday in the schoolyard, and I was going to give it back to you after the contest today. But I needed it to win. But you did win. Yeah, I did. I did. I did.
You did it all yourself, Oni.
All by myself. Like I said, it doesn't work. I had it in my pocket all during the contest, and it didn't help me. But then what about all the other good luck I had?
They must have been good things that just happened to happen.
I guess they were. I guess that's true. Well, anyhow, it's a pretty stone.
I wonder what'll happen if we keep doing this.
I'll tell you what.
The only thing that'll happen is something might drop on your heads. Watch it, you guys. A ladder means workman, and I'm pruning this tree.
Those puppets and their wacky adventures. Yeah, so that's a thing about superstition. Okay, this next film is an Encyclopedia Britannica film, and it's awesome. I love it. It has a portrayal of what space travel is going to look like before we actually started traveling in space. So here's Trip to the Planets. And it has, I don't know who the scientist is, but boy, he is a stereotype of a scientist from that time period. Enjoy.
I am Wally Lai. As one of the pioneer writers about space, I watched ideas I wrote about 20 years ago become everyday fact. Now I want you to come 20 years into the future with me on an imaginary journey to the planets. The journey is fiction, but the facts about the solar system and about the planets are as accurate as science can make them today.
Minus 45 seconds. Minus 40 seconds.
Telemetry and launch condition.
Affirmative. Minus 35 seconds.
Pressurization complete.
Affirmative. Minus 30 seconds.
Lock tanking secured.
Box tanking secured. Minus 25 seconds. Minus 20, 19.
Imagine you were in the shuttle boat with Willie Lay, poised above the powerful booster rockets, ready to begin our trip to the planets.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire. Mark.
Our trip to the planets has begun. The smaller streamlined shuttle carries us through the thick atmosphere of Earth toward the larger interplanetary ship. In the vacuum of space, the interplanetary ship coasts in a parking orbit, waiting for our space taxi. We slowly overtake the giant ship and prepare to attach ourselves to its side so we can board it. Our spaceship roars out of its parking orbit.
Back on Earth, when we plan a trip, We know that San Francisco will be 2 weeks from now where we left it today. And we know that we will find London where it was 3 years ago. But when we start traveling in space, our destinations keep moving at different speeds, and travel plans become a great deal more complicated. Fortunately, all of the 9 planets and their moons, the thousands of asteroids, and most comets move around the sun in the same direction and nearly in the same plane, which somewhat simplifies our navigational problems. We are headed toward the sun now. It is very much like going downhill, because the sun's enormous gravitational field pulls our ship toward it, just as it pulls all other bodies in the solar system toward it. But as the planets whirl around the sun, centrifugal force counterbalances the gravitational attraction. These two forces, centrifugal force and gravitational pull, are opposite and equal, which keeps the planets in their orbits and prevents them from flying out or from approaching the sun too closely.
The sun's gravity and our own momentum have taken us as close to the center of our solar system as we can safely go. So the captain turns the ship around. The engines are fired in the opposite direction to reduce our speed. The sun is gigantic. If it were hollow, 1,000,000 Earths could fit inside it. And it's noisy, too. This tape recorder is reproducing radio waves from the sun that are striking the outside of our ship. The sun is the source for almost all the energy in the solar system. But how does it produce this tremendous energy? Scientists believe the sun is mostly hydrogen, and the tremendous weight of such a huge mass creates superpressures and supertemperatures within its center. Under these conditions of enormous heat and pressure, hydrogen is turned into helium. But in the process, a small amount of mass is released as energy. This energy works its way slowly outward to the surface, relayed from atom to atom. It might take 50 million years for this energy to reach the surface of the sun, but it will take just a little over 8 minutes to get from the sun to Earth. Moving on past the sun, we approach Mercury, the smallest planet. Mercury is barely half again as large as our moon, while Venus is almost as large as our Earth. Scientists speculate that when Mercury was still a rotating and condensing sphere, the sun's strong gravitational pull caused huge ground tides on the planet's still soft surface. When Mercury finally cooled, these bulges hardened and began rotating with the rest of the planet, until the strong pull of the nearby sun on these bulges slowed the planet down. Now it can no longer achieve complete rotation, but only yaw slightly from side to side, keeping one face continually toward the sun. On the sunlit side, the sun's rays strike directly and eternally against the rocky surface and raise its temperature to about 700 degrees Fahrenheit. In contrast, the temperature on the dark side is 450 degrees below 0 Fahrenheit. The next planet out from the sun is mysterious Venus, hidden for centuries from our optical telescopes by dense clouds. Until we actually penetrate the cloud layer, we can only speculate about the surface of the planet. But we know energy from the sun filters through the clouds, heating the surface to 800 degrees Fahrenheit. However, the heat which comes back from the surface is trapped under the clouds, raising the temperature of the atmosphere. This heat once caused speculation that if water were present, the surface of Venus would be a vast, boiling ocean. The first Mariner space probe indicated that Venus is a dry, lifeless desert, since water could not be present at a temperature of 800 degrees Fahrenheit. Already, Venus appears smaller as we speed on toward the orbit of our own Earth. A day and a half later, just beyond our Earth, Mars looks like a red star. Still later, as we approach its orbit, we see that Mars has two tiny moons, the largest only 10 miles in diameter. Each spring, dark areas of the planet have been observed turning into a green-blue color, and scientists are fairly certain this seasonal change is caused by a simple form of plant growth. We're leaving our spaceship in a parking orbit about the planet to take the shuttle boat down for a closer look. The red coloring of the deserts of Mars may be caused by oxidation of iron in the large patches of sand and rock. Even in this thin Martian atmosphere, the winds develop high speeds. And with so much light sand on the ground, dust storms are frequent. It's a desolate landscape, and yet one can't help wondering if long, long ago, before the planet lost most of its air and water, there was ever intelligent life on Mars. A larger ship than ours, with a full team of geologists and their equipment, may one day give us the answer. When we leave Mars, we leave the group of inner planets. These planets near the Sun, including our Earth and Pluto, the outermost planet, have certain characteristics in common. They are all relatively small, solid bodies composed of rock and metal. Because they are Earth-like, the Latin word for Earth, terra, is used, and they are called the terrestrial planets. Just beyond the inner planets is a ring of thousands of orbiting rock metal fragments ranging in size from a grain of sand to several hundred miles in diameter. These are the minor planets, or asteroids. Beyond the asteroids is the first of the gas giants, Jupiter. In fact, Jupiter is the largest planet in the solar system. The enormous speed of Jupiter's rotation pulls the gaseous surface into bands. The great red spot may be clouds over a huge floating mass of solid material. If we compare the Sun, Jupiter, and the Earth, we realize the great differences in size between the Sun and planets. Jupiter has 12 moons. The largest two are each as big as the planet Mercury. Some of the others are too small to be seen without a telescope, even this near the giant planet. We put our ship into a parking orbit again and take the shuttle boat for a look deep inside Jupiter's atmosphere. We don't really know what lies beneath the thousands of miles of atmosphere, but we're fairly certain that Jupiter and all the other giants are predominantly hydrogen. The surface temperature is very low. These outer clouds of the planet are probably made of frozen ammonia crystals suspended in an atmosphere of hydrogen and methane gas. Violent electric storms and winds of cyclone force churn the atmosphere. A blast of wind catches our wings. It flips our shuttle boat over and over, pulling us down deeper and deeper into Jupiter's unknown depths. The captain fires the rockets, and the boat surges forward, gradually moving upward to the outer edge of Jupiter's atmosphere. Now we must travel more than 400 million miles further out from the sun to get to our next target, Saturn, surely the most unusual planet in the solar system. Besides its beautiful rings, Saturn has 9 moons. One of them, Titan, is the largest moon in the entire solar system, larger than the planet Mercury and almost as big as Mars. It is the only moon in the solar system known to have an atmosphere. And this atmosphere is mostly methane, a gas poisonous to man. At this enormous distance from the sun, ammonia and some of the methane is frozen and looks like snow. The rings of Saturn are nearly 200,000 miles wide, but they are so thin they virtually disappear when seen on edge from a telescope on Earth. They may be no more than 10 miles thick and from a distance look quite solid, but the closer we get to them, the less substantial they appear. As our boat coasts into the outer ring, we find ourselves surrounded by billions of particles the size of grains of sand. Most of them are ice crystals, and they all glisten brilliantly in the sunlight. The remaining gas giants, Uranus and Neptune, are much like Saturn, except they have no rings. But since distances, even in our tiny solar system, are so immense, there isn't time to visit them. For even at 1,000,000 miles an hour, a trip back to Earth from Pluto at the outer edge of our solar system would take 5 months. Approaching Earth, the captain turns the ship around one last time. The rockets are fired to slow our descent to Earth.
Home looks good to us. It has an abundance of oxygen and of water and of the things we need for life. We're used to the length of its day and to the changing of the seasons. Yet we cannot help being curious about the planets. And one day, one of you who are watching now may be on the ship that makes the trip, which was only imaginary today.
I love that. I absolutely love that. Okay, it's been a long time, and I know that we need a refreshing. Oh, by the way, so YouTube responded to me and had me fill out a form. And they said that they'll get back to me within 24 hours. So, fingers crossed. The hilarious thing is that I set up with that channel. I set up scheduled releases of films. So films are showing up, and they didn't take the time to stop them, and everything that they've done, they've made private. So I don't know if they're going to try to extort money out of me or what the deal is, but there you go. So that's what we have regarding trying to get my other channel back. But I'm happy you guys are watching me on this channel. Anyways, pocket calculators. Let's refresh. Enjoy.
Millions of people use pocket calculators every day. They may be used in drafting or by salespeople in showrooms. There are hundreds of different uses for calculators and a surprising variety of specially designed calculators to do certain jobs. There are calculators that are programmable, just like a computer. Others are designed to handle scientific work, accounting, or banking.
You can even find calculators that fit your wallet or that have clocks. And would you believe that there are even calculators that can talk?
4, 9, 6 equals.
They're built specifically for blind people. Except for talking, they work the same way as other calculators.
7 equals 6, 3.00 square 9.
But with all the different styles and features available, how can you pick out the right personal calculator for yourself? First, you should have some idea of what you want it to do and how much you can afford to spend. You'll probably want one that can at least add, subtract, multiply, and divide. There are other things to consider in choosing a calculator for yourself. For instance, it's nice to have keys that click, so that when you push a key, you know that you've entered the number. You'll probably want it to be strong, so that if you accidentally drop it, it won't break. You may want it to be an algebraic calculator, so you can enter the problem in the same way that you would work it on paper. There are other kinds. If you should choose a different type of calculator, you'll need to learn how to operate it from the store clerk where you bought it, or from your teacher. No doubt you'll want a good warranty so that if your calculator goes bad, you can send it back and get it repaired rapidly and economically. Make sure that the display is easy to read. Some calculator displays are harder to read than others. And make sure that the calculator's keys fit your fingers easily. No particular kind is better than another. It's up to you and what you're looking for in a calculator. When you get a new calculator, you'll want to see how it works. You can start with a simple addition problem, 26 plus 49. Before you start any computations, always press the clear key. To add these two numbers, you first enter the number 26 in your calculator. To do this, press the key labeled 2, and then press the key labeled 6. Now the number 26 is shown in the display. Next, press the plus sign. Now you enter the other number, 49, by pressing the 4 key and the 9 key in that order. Notice that the number in the display is now 49. Now that you've entered both numbers, you just push the equal key and the answer to the problem, 75, appears in the display. Now suppose that you have 3 or more numbers to add. The problem is 43 plus 37 plus 22. To work this one, you go about it the same way. You enter the first number, 43, by pushing the 4 key and the 3 key. Then press the plus key. The next number to be added is 37. So you enter it by pressing the 3 key and the 7 key. Then push the plus key. The last number to be added is 22. Enter it by pressing the 2 key twice. Now that all the information has been fed into the calculator, the final step is to push the equal key. And the correct answer appears as 102. Now that you've mastered adding with the pocket calculator, we can move on to the next function, subtraction. But remember, before starting a new problem, always press the clear key to get rid of any numbers that may be stored in your calculator. Subtraction is done the same way as addition, but using the minus key instead of the plus. To work this problem, we enter the first number, 297. To do this, you press the 2 key, 9, and the 7. The number you've entered, 297, now appears in the digital display. Since this is a subtraction problem, you press the minus key. Next, enter the remaining number, 137, by pressing the 1, 3, and 7 keys in that sequence. The number 137 should appear in the display. Now all you need to do is press the equal key and the answer appears in the display as 160. Here's a real-life subtraction problem. Suppose you have 297 football trading cards and give away 76 of them. The problem would be 297 minus 76 equal. Press the keys in the correct order, and you got the answer, 221. You'd have 221 football cards left. But be careful. Sometimes subtraction problems come out with negative numbers. Try 37 minus 47, and the display will show minus 10. Now let's try multiplication. The problem is 67 times 47 equal. Just as in addition and subtraction, you begin by entering the first number, 67. Press the 6 key and then the 7 key. Now, since this is a multiplication problem, press the times key. You're multiplying 67 times 47, so you enter the 47 in the calculator by pressing the 4 and the 7 keys. After pressing the equal sign, the answer, 3,149, shows up on the display. Let's try a multiplication problem in a grocery store. If you know that there are 72 packs of pop and 6 cans to a pack, how many are there altogether? By multiplying 72 times 6 on the calculator, the answer is there are 432 cans of pop. But be careful. You may multiply numbers that give an answer larger than your calculator will display. If the number is too large, the calculator's display will either flash the numbers on and off or flash a line of ease. If the number is too large, you'll have to find another way to work the problem. Another function that the calculator performs is division using the divide key. Division problems are solved in a similar manner to addition, subtraction, and multiplication problems. Suppose you want to divide 923 by 46. You enter the numbers in the same way you have with the other functions, 9, 2, 3, divide, 4, 6, equal. If you have an 8-digit calculator, the answer shows up as 20.065217. Let's try another division problem. Suppose you have 438 trading cards that you want to divide equally among 6 friends. The problem is stated 438 divided by 6 equal. So, using the calculator, you enter 4, 3, 8, push the divide key, enter 6, and push the equal key. The answer is 73. So 73 cards would go to each of your friends. Now that you know how to perform the 4 basic functions with your calculator, addition, subtraction, multiplication, and division, let's try something a bit more complicated. Here's the problem. 36 minus 21 times 43 plus 62 divided by 3. If you work this problem across from left to right on the simplest calculators, as you've done in the previous problems, you'll get the wrong answer. Let's try it that way. She enters 3, 6 minus 2, 1 times 4, 3 plus 6, 2 divide 3 equal. The calculator displays 235.66666. That's not correct. Can you guess why the answer is wrong? She ignored the parentheses. In solving this kind of problem, you have to work the parts in the parentheses first. You do the problem in several steps, starting from the left. First, enter 36, subtract 21 on the calculator. The answer is 15. Record the 15 on a worksheet. Then clear the calculator. and add 43 plus 62. The answer is 105. Write down 105 on the worksheet and clear the calculator. Now, using the calculator, you multiply 15 times 105 for 1575. You write down 1575 on the worksheet. Then divide the 1575 by 3, and the correct answer is 525. If you're using a more complex calculator that's equipped with parenthesis keys, you can work this problem in just one step if you make certain to use the parentheses when entering the problem in your calculator. Many calculators are equipped with a percent key. Calculating percentages can be a very useful function. For example, suppose you saw a new racing bike that cost $175. It's advertised at 15% off plus 5% tax. How much would it cost? Here's the way the problem would be stated. But in order for your calculator to handle the problem correctly, it will need to be treated like this. Notice that the 175 minus 15% is placed within parentheses to be worked separately. You would enter 1, 7, 5, minus 1, 5, and press the percent key. At this point, push the equal key. The answer appears as 148.75. This means that at 15% off the retail price of $175, the bicycle would cost $148.75. But now you have to add the 5% tax. The 148.75 is already in the calculator, so you just press the plus key, then 5, then the percent key, and finally the equal key. The answer is 156.1875, or $156.19 is the total price of the bicycle. Other function keys are the square root and square of a number keys. If you wish to find the square root of a number, such as 64, enter 64, push the square root key, and the answer is 8. Or if you wanted to square a number, you use the x squared key. Let's enter 8 and square it. The answer is 64. So you can see that the square root key and the square key, in a sense, cancel each other. To see this, let's try 5 squared is 25. The square root of 25 is 5. Many calculators also have memory keys. If you have this type, find out how your particular model works. But in the meantime, you can use the basic functions you've already learned to do many things. For example, suppose you wanted to quickly find out how many minutes there are in a year. That's a big number. There are 365 days in a year, times 24 hours in a day, times 60 minutes in an hour, equals 525,600 minutes in a year. So hard or long computational problems are made simple. When your parents go shopping, you could go along and calculate the best buys in the grocery store. For example, the best unit prices on different sizes of detergent. Or you might add up the grocery bill as you go. You could also use the calculator to check your math homework. But be sure to get permission from your teacher before using your calculator to work school math assignments. Remember, no matter what kind of calculator you use, you still need to know how to add, subtract, multiply, and divide, because you must know how to set up the problems. So don't become too dependent on your calculator. A calculator is fast, accurate, can handle large numbers. It is fun to operate. But it takes a trained person to make it perform properly. You.
So I guess I had Casios, and then when I was in college, I got a TI 66, which was a programmable calculator, and then promptly lost it. I paid a lot of money for it. I think it was like $200, and then left it on the brickyard at NC State, and then it was gone. All right, what do we got? Last film. This one is, I think this is BFA. This is Discovering the Music of Japan. This is part of a series. They did a lot of discovering musics. We saw the one with electronic music. So, enjoy.
Japanese music, like Western music, has a long tradition and many famous composers. Three of the major Japanese instruments are the koto, the shakuhachi, and the shamisen. Let me first acquaint you with the koto. Like many Japanese instruments, the koto originally came from China and was introduced to Japan during the 8th century. At first, the koto was played only by the people in the palace. Then, about 350 years ago, a blind musician named Yatsuhashi was taught to play the koto by a friend of his who was a musician in the palace. Yatsuhashi, in turn, shared the koto with the common people, and though it became a very popular instrument, his friend lost his job at the palace. Yatsuhashi is called the father of koto music. This beautiful koto is over 200 years old. It has 13 movable bridges, one for each string. The koto is played by 3 ivory picks. The Japanese scale is different from the Western scale. Instead of being divided into 7 tones, the Japanese scale is divided into 5 tones. In koto playing, the right hand plucks the strings. The left hand can press a string to make the tone higher. Or it can pull a string to make the tone lower. In modern koto playing, the left hand, as well as pressing and pulling, can pluck the strings in the same fashion as the right hand. Let's listen to a part of a composition by the father of koto music, Yatsuhashi. This piece, Rokudan, is one of the oldest known compositions for koto. The koto is used today not only in the imperial palace, but also in religious ceremonies, in concerts, and in the home, much as a piano might be used. Here is a part of a modern composition by Yuise. It is called nagare, which means murmuring waters. Many Japanese compositions, like much Japanese art, describe nature. Now that I have acquainted you with the koto, let me introduce another important instrument, the shakuhachi. It is a flute made of bamboo. The sound is produced by blowing across the sharp edge in the mouthpiece. The different tones are made by covering the holes in the shakuhachi. The wavering tones, which are so unique to the shakuhachi, are made by the movement of the head. It is thought that the shakuhachi came from China during the 16th century, a time of civil wars in Japan. Many Japanese knights, who were called samurais, lost their knighthood and became wandering Buddhist priests. Since priests were not allowed to carry weapons, these former warriors used their shakuhachis to defend themselves. Fortunately for them, the old shakuhachis were shaped very much like clubs. Let's listen to an example of the music played by these wandering Buddhist priests. A prayer played on the modern shakuhachi. You'll notice that the music he reads is different from the music you are used to reading. It is read from top to bottom and from right to left. Now let's listen to this musical prayer. Along with the koto and the shakuhachi, another very popular Japanese instrument is the shamisen. It is an instrument somewhat like the American banjo. It can either be played by the fingertip or by a large pick, usually made of ivory. The shamisen can play a melody. It can also act as a rhythm instrument when the pick strikes both the string and the body of the instrument. The combination of the rhythm and the melody makes shamisen music very exciting. The shamisen was introduced from the island of Okinawa in the 16th century. At first, it was made out of the skin of a snake. Here is a very old instrument made out of snakeskin. But because there weren't large enough snakes in Japan, the Japanese used the skins of domestic animals. The shamisen was once used mainly to accompany long songs of battles, heroes, and romantic tales. Today, it is used in the theater, in the concert halls, and is a popular instrument to accompany songs and dances. The instruments we've studied are often played together. To finish, let us listen to the koto, the shakuhachi, and the shamisen as they play together. The composer of this piece was a very famous Japanese composer who died only a few years ago, in 1959. His name was Miyagi, and he was also a blind koto player. This composition describes the raindrops falling from the roof of a house.
so much promise, and then it got super splicey at the end. And what that means is that somebody rewound it and then maybe let it like on an inspector, and what happens is that often goes really fast, and if you're not keeping an eye on it and it doesn't stop, then it starts shredding. The film starts like becoming confetti, and so it's possible that's what happened. Is that it just blew it into pieces, and then somebody tried to splice it together, or somebody didn't thread it right. Like they basically started running the film back through the projector to rewind it, and it lost the loop and just shredded. That's another thing that happens. So films have long stories that they tell, and sometimes those stories are not the happiest. So, but thank you for watching today. I very much appreciate. I was telling Katrina, my wife, last night that how great it was to see all your smiling faces, and you're getting your support. I'm getting emails from people saying, "What's happening? What's going on?" And so I'm hoping I get the channel back this week. I have no reason to believe that will actually happen, but hope springs eternal. All right, love you guys. We will see you tomorrow. Everybody take care.